Hello, I'm Krishna Srivastav and I'm presenting my fast API observability stack project for the backend engineer internship at Vibe Monitor. Today I will demonstrate a complete observability solution that implements the three pillars of observability: metrics, logs, and traces, all integrated into a fast API solution. Let me walk you through the architecture. At the center, we have a fast API application instrumented with OpenTelemetry for distributed tracing and Prometheus metrics. The application runs in Docker containers alongside our monitoring stacks. Hello, I'm Krishna Srivastav, and I will be presenting my solution for the backend engineering internship at Vibe Monitor. I will demonstrate a complete observability solution that implements the three pillars of observability: metrics, logs, and traces, all integrated into a fast API application. So let me walk you through the architecture first. I have created this fast API application instrumented with OpenTelemetry for distributed tracing and Prometheus metrics. The application runs in Docker containers alongside our monitoring stack. So here's how our flow would look like. For metrics, our fast API application generates HTTP request data. Prometheus grabs these metrics from our /metrics endpoint, and Grafana queries Prometheus to visualize the metrics in dashboard. And for logging, our application writes structured log entries. These logs are collected by Loki, either through a log agent or direct shipping. Grafana then queries Loki to display and search through our logs. For tracing, OpenTelemetry in our application creates spans and traces, as you can see here. And then Grafana connects to Tempo to visualize the distributed traces and span details. For ease, I will go through the code after showing you how the dashboard and all works. So for ease, now I have created this script which is run.sh. This script, it can deploy the entire 6 service observability stack. This script handles cleanup, builds our custom fast API container, orchestrates all services, and provides URL. So as you can see here, our Docker containers are running, which means our services are running, and those are running from past 31 minutes. So let's move on to the dashboard and let's create the dashboard first. So we'll use 3 queries. The first query will be to show the overall request rate per second. The second query will track the P95 latency, and the third query will show you the average response time calculation. So this is how our dashboard would look like. Let's generate the traffic and let's observe the low key. I'm using Hey to generate the traffic, and we will be hitting this URL slash trace endpoint, which creates traces, and then we can it returns the output as it shows the latency as we have uh, latency from 0. It simulates the latency by create from 0.1 to 0.5 a random number, and then it gives you the trace endpoint. So let's see the tempo here. In the tempo, we have this service, fast API service, and if I click on this trace ID, it will get expand. And as you can see here, we have this parent span and two child spans. Parent span, it represents the entire HTTP request lifecycle, and these child span, it shows internal operations like HTTP request response handling. And let's So this query, it shows me the request per second rate over the last 5 minutes, and this green line, it represents get request uh, to our slash metrics endpoint, and this yellow line represents the get request to the slash trace endpoint. And as you can see, this green line is stagnant because Prometheus sends regular uh, request request to slash metrics endpoint, and our yellow line, it has spikes because it hits our custom endpoint the when we generate the load. This is how our dashboard would look like. Let's walk you through the Let me walk you through the code. So I have configured the logging at the info level, and then I've created the resources. Uh, Wait a minute. Yeah, I configured distributed tracing with OpenTelemetry, sending trace data to Tempo via OTLP protocol on port 4317. have implemented three types of auto instrumentations. Prometheus, automatic HTTP metrics. It sends this line. It sends automatic HTTP metrics, and then fast API tracer. It automatically creates the span for each endpoint, and then this log instrumentation, which correlates logs with trace ID. And we have three endpoints, slash and slash trace and slash help. Uh, this endpoint slash trace, it creates custom span with attributes. It simulates the variable latency from 0.1 to 0.5 seconds, and then creates a child span with custom attributes that will be visible in Grafana's trace view. And in our Prometheus YML, it scrapes interval for every 5 seconds and evaluates the interval every 5 seconds and creates the job name fast API, and it tells the Prometheus to hit the target of the fast API service at 8000 port, and the endpoint will be slash metrics for every 5 seconds. Uh, Tempo, it listens on 3200 port number, and it receives traces via OTLP on port 4317, the same endpoint my fast API exports to, and then uh, it configures local storage for development, but in production we can use the object storage like Amazon S3, and it has 1 hour retention, keep storage manageable for demos while showing trace data. Then Loki, it aggregates structured logs from our fast API application. It listens on port 3100, and uh, it uses timescale database, mm, uh, and it has file system storage, works for local development. Production, we would use object storage. Prompt tail, it listens on 9080, and then uh, the pipeline storage in the pipeline stages parses JSON formatted Docker logs and extract the actual log content. This gives us centralized logging without changing any application code. Grafana data sources. Yeah. It provisions all the data sources automatically when Grafana starts. Configured trace to logs correlation. So clicking a span shows relevant log entries. Trace to metrics correlation. Let me jump from traces to performance metrics. And not Docker compose file. Let me show you the Docker compose file. We have 5 services: Fast API, Prometheus, Grafana, Loki, and 6 services. Tempo. Fast API, it depends on Tempo and Loki, which means Tempo and Loki should be running before we run our Fast API. It exposes port 800 and 8000, and it exposes this endpoint uh, http slash tempo 4317, and it has it creates three rotations and supports maximum file size up to 10 MB, and JSON, it supports JSON file driver. And for Prometheus, we have used the Prometheus image, and it creates the Prometheus container with and exposes 9090 port, and then from our prometheus.yml it creates the volume at slash for Grafana. It exposes the port 3000, and it depends on Prometheus Loki and tempo, which means Prometheus Loki tempo should be running before running our Grafana. And it creates the environment with uh, admin as user and admin as password. And same for Loki, it exposes 3100, and Promtail it exposes. It depends on Loki, and it copies the Promtail config YML to slash etc slash Promtail slash Promtail config YML. In tempo, it exposes 3200 and 4317, and it creates a network observability. So this is our dashboard, and our logs we can see here. As you can see, for every 5 seconds, the slash metrics endpoint get hit by the Prometheus. So it's showing log here. Let's generate some traffic and let's see. When we generate traffic, for every milliseconds, the logs are getting logged. Now, let me show you by executing this shell file. All the services are up. As you can see here, it started 21 seconds